In this part of the course, we're going to be talking about continuous probability distributions. In the last part, we were talking about discrete probability distributions. So this time, I want to talk a little bit about how those compare to each other. We didn't really look at discrete probability distributions like a graph like this. This is a histogram of if we flip a coin twice, what's the probability we get both heads was 1/4. One of each was 1/2. The probability we get both tails was also 1/4. And we know from what we discussed before that all of those probabilities, if you take the probability of each event, they all have to add up to 1. Here, we can look at this as being a histogram with the width of each of these is 1, and the height is the probability, and we have an area of those 3 bars adding up to 1. Now that's for discrete, right? We only get 3 possible outcomes. But remember, with continuous, we have to account for all the variables in between. You don't go right from 1 to 2 or 2 to 3. You have to go through all of those numbers in between, which means there's not just going to be 3 possibilities. There's going to be an infinite number of possibilities. This would be another discrete distribution with a whole bunch more outcomes. All of those areas still have to add up to 1, which means the area of each individual rectangle is getting much smaller here. If we take that to extremes, if we say we're going to have an infinite number of rectangles, right, one for each number on the continuum, and there will always be an infinite number of numbers on a continuum, then what we really end up with is line segments here, which don't have any areas. So we can't really calculate the probability of a specific thing happening. We instead need to talk about a range of things happening, because the probability of any one thing actually is 0. So the function that gives this curve is called a probability density function instead of the probability distribution that we dealt with before. And when we talk about finding the probability of something happening, we talk about the probability that we're going to be within a range of numbers. So we talk about the probability we're going to be here, and we're going to find this area. Now the area under the entire curve has to be 1, right? Because that's the probability of something happening, and if we're talking about a trial, something always happens. So we're dealing with different curves that will have an area underneath them of 1, and when we talk about finding the probability, we're finding the probability of a range of events, either greater than, less than, or between. So I could talk about finding the probability of being farther up than that, or between these two, or below there. And we're going to be looking at 3 different types of continuous probability distributions: the uniform, the exponential, and the normal. We've already looked at the normal. If you remember the empirical, that's 68, 95, and virtually all, that deals with that normal distribution. We're going to go deeper into that idea in this part of the course. And for each of these distributions, this is what I'm going to expect of you. I'm going to expect that you understand the mean and the standard deviation. Sometimes you'll have to find it, sometimes it's given to you, both of them. Finding the range of likely outcomes, meaning, where's that 95% majority of the population. Be able to find the probability that you're above a certain point, below a certain point, or between, just like here. Find a percentile. So 95% of this distribution is below what number, right? So you find, boom, where that cutoff is for the top 5%. And then an idea that we call the central limit theorem. We'll end with that, and that'll sort of get us into the 4th part of the course. All right, so that's where we're headed with this. Time to get started.